Okay, after wiring the servo, I'm plugging the servo to my proto board. I want to test it. I'll show you the code that you will need to write. I will also share that. To test it, you know, servos, when you first get them, they have this little ping on the top, the shaft, and it's kind of hard to see what's going on. So when you're testing them, what I like to do is I put a little arrow. I made this one by using a cable tie like this one. This is like you can find in any hardware store. They're super cheap. And basically I just did this to it and left a little opening, cut it to size, and then just cut a little arrow out of cardboard. I left it here prepared. But yeah, this is, you can do whatever you like. This is where you can get creative. This is a physical thing, so you can sketch with the materials that you know and do something that maybe applies to your use case. But for the time being, let me fix the focus of the camera. Hello, please refocus down here. Let's see. Come on. Right. Yeah, sometimes the camera wants to do something else. I also made the setup of the servo a little bit more stable, because once it starts moving, it's going to go all over the place. So I taped the cables to the cutting mat, and I put a little bit of tape to it. And now I'll show you how to run a servo with the feather board. Right. So the first thing we need to do. This is my Arduino environment, okay? So this is just what you see when you have when you start a new project. And the first thing we need to do is go here to manage libraries, because servos and feather boards don't get all that well along together. I'm gonna make this a little smaller so that it fits. I can't make that smaller. Alright, so ESP32 servo, that's what you need to search for. And what that will do is it will go to the library repository of Arduino, and it's going to try and find a library by the name of ESP32 servo. As you can see, in my case, I have it already installed, but you will need to install these if you have never used this board before. That's because this board works a little bit differently than the standard Arduino, so in order to move a servo around, it needs a different library. And then I'm simply going to get to it. So the way we import the library is into our code is by typing this statement include, which is preceded by a hash pound, a hash sign or a pound sign, I think this is called. The language that you program Arduino in is called C++. It looks a bit like JavaScript, but it's not really like JavaScript. It's older than JavaScript. But Arduino gives us, let's say, a reduced version of it, a more accessible version of it. It makes it a little bit easier to work with. But there are a few quirks in the syntax that are a little different than JavaScript. So for example, the library name, which is ESP32 servo.h, everything is case sensitive, by the way. So if you type small s, then it will not find the library. First, okay, it wants me to save it. IoT F28 servo2, I'm going to call it. As you can see here, there is an error. When I press invalidate, there is an error because it doesn't find, it says no such file or directory, compilation terminated. So it doesn't find ESP32 servo with small s. That's because everything is case sensitive in C++. It also is incidentally in JavaScript, by the way. So this is a distinction that is important to make in both languages. I'm going to bring the window back again so that they're side to side in the stream. Right, so if I try to do that again, you will see that that error will not be there anymore. It successfully compiled the sketch, quite probably. But this sketch is doing nothing. Now, then again, if you remember from the days of P5.js, there is a setup and a loop. The setup is code that is run only once when your board is powered for the first time, and the loop is running constantly as long as your board is powered. The first thing I need to do is to create a variable called servo, where I'm going to wrap my servo around. So this thing comes from that library. So as you can see, servo is in orange because Arduino environment finds it somewhere in the libraries. If this doesn't get orange, it means that you mistyped it. For example, if I try the lowercase, you will see that it doesn't go orange. So make sure that it's orange to be absolutely sure that you're okay. The next thing I need to do is I'm gonna start serial communication, which is a way of telling the board that I want to talk back to the computer. This is we use for debugging and to be able to see what's going on inside of the board. This is standard, so you can copy and paste this. This we always have to do. While, sorry, I mistyped that. Is while serial blah blah blah. So what this does is it basically it starts a serial port. This number over here, mysterious number, is the speed of communication between your desktop or laptop and the little board, and then we just wait for a serial to start calling. And then what I need to do, is to attach the servo to a specific pin. So we do that with that statement. Servo attach. Again, everything that you see in orange is because Arduino recognizes it as a keyword or something that is defined in the library somewhere. So here we're going to use pin 12, I believe. We put it in. And then one thing that I like to do is this 12, after a little while, let's say that we want to change this pin number. After a little while it might be a bit obscure why there is a 12 there. So normally I like to give those a name. So over here I'm going to define something called pin servo, and I'm going to give it a 12. So then I can use this keyword instead of the actual number here. And then this reads a little bit more natural, so servo attach to the pin of the servo. This is not only for readability, but also because, let's say, if I have multiple statements, this often happens with sensors, if I have multiple statements that refer to the pin, then, you know, if you change in your electronics the pin where, if you rewire your electronics so that the pin is different, then you have to go in the code and then change it in every single instance, and that can get annoying. In our case, we only have one instance, but I like to do this so that is, you know, this is good practice. So I recommend that you do it as well. And instead of using magical numbers through your code, just pick a name and use the name instead. It will make your code more readable. And then for the purpose of the test, I'm just going to do something super simple. So the way you operate a servo is by writing the angle to it, so what angle you want it to be. So at first we start in 0 degrees. See how in C++ we always put a semicolon at the end. I've been doing that, but I didn't talk about it yet. So we always put a semicolon at the end of every statement. In JavaScript, this semicolon is optional, but in C++ it's not. So if I do that and I forget the semicolon and I validate the sketch, you will see that I get some kind of strange error. It says that servo was not declared in this scope, whatever that means. And what that means is that I forgot here a semicolon. And then if I recompile again, you will see that this time it works. Now, I guess that this is why people hate programming, because a misplaced semicolon can really throw you off and give you an unreadable, mysterious error message. But it helps to learn how to be less afraid of error messages. Error messages are there to give us clues about what might be going on. But I can totally understand that at the beginning it can be a little bit intimidating. So at first I'm going to put the servo on the angle 0, then wait for a second. The delay, what the delay does is it waits, and you specify how long it has to wait in milliseconds. So this is in milliseconds. I just added a comment here. This over here is a comment. Now I know that most of you already know that, but not all do, so I don't mind repeating or going over things that might be pretty straightforward. Then I set it to angle 30, and again I delay for another second, and I'm gonna do this 3-4 times. Let's do that 4 times, and at every time I'm gonna set it to a different. So what I did is copy and paste. I selected 2 lines, I copied, paste, paste. Now I have one too many. Alright. And here I'm going to set angle 60, and here I'm going to set angle 90, and I'm yet going to go one further and do 120. So then we would have something like a movement that has like 4 different stops. It starts at angle 0 and it moves all the way to angle 120. Whoops, let's correct that. That was 1,200, that's way too much. 120. So if that works fine, then we should see the servo move accordingly. And then I'm going to change the code around so that hopefully it becomes a bit more clear what the code is doing. And that's it with these 26 lines of code, out of which half of them are copied and pasted. Hopefully we should be able to get some movement out of this thing. Let's see. Now it's loading the code onto the board. As you can see, the process involves two button presses. One to verify the code, and the other one to upload to the board. And then it takes a few seconds to upload. And it tells us here, done uploading. And I don't see any movement happening. Did I do that correctly? Crap, I forgot this thing. Sorry. Okay, so it's stuck waiting for serial, of course, because I forgot that. You will not forget that, because I'm going to give it to you in the class notes, and you are just going to cut and paste that little bit there. But I had forgotten to type it. So that exclamation mark says while serial is not ready, so while not serial, then just wait. But I forgot that bit. So then my board got stuck there. You see? Alright, so what's happening there? First of all, it's hitting the cable. Wow, what a disaster. Okay. Come here, you little screw. Yeah. I'm going to push you back. Yeah. Alright. So what's happening here is that I made another little mistake in this program, and that's that the first movement, so it moves to 0, then it waits for a second, so that's 1000 milliseconds, and then it does go to the other positions, but in between it only waits for 100 milliseconds, which is actually too fast. So it seems like the second part of the movement is kind of staggered. I'm going to change this so that we have another kind of motion. So when we change the duration between every step, what we are doing is also changing the way that this thing kind of animates. We're doing a physical animation, so an animation that actually takes place out there in the world of atoms, not only in the world of bits. And now I'm ready to upload. As you can see, the code continues to run. This loop is constantly running for as long as the board is powered. So here we basically have an animation. This is the frame, then wait, frame, then wait, frame, then wait. There we go. Okay. So that's what we want to do. Ironically, the arrow actually casts a shadow over the light sensor at some point. So it could be cool to play with feedback on this thing. But for now, all I wanted to do is just show you how to basically write the code to test the servo, and go over the little details, some intentional mistakes also, so that you see the possible errors that you're going to encounter, and some non-intentional mistakes that I screwed up on. But yeah, that's it. That moves the servo. So save this sketch as the little sketch that you're going to test your servo with. We are going to do another sketch for testing the light sensor, and then we will put everything together, including reading and sending MQTT messages to have a functional device. Alright, that's it for this video. I'll see you in the next one.